Hi, this is Pratik and welcome to Code Verify. In this video lesson, we'll learn about a depth-first traversal in a graph. You can also call this as DFS, which stands for depth-first search. So basically, you can do depth-first search by using depth-first traversal. Now let's take this graph as an example. So in this graph, I can present this graph as an adjacency list. So in this adjacency list, there are key value pairs like 0 is connected to vertex 1 and 2, vertex 1 is connected to vertex 0, 3 and 4, and vertex 2 is not connected to anything, and so on. So if I was supposed to do depth first traversal of this graph, so then if I start from the root node, that is 0, then the depth first traversal would be start from the root node and first reaching the vertex 1 and then reaching vertex 3 and then reaching vertex 4 and then finally reaching vertex 2. So one thing you could see that if I started from the root node, then I went as deep as possible in this branch. So that's why the name depth first. That is, we go as deep as possible. So first we go to 0, then 1, and then 3. So after 3, we cannot go deeper to that. And so therefore we moved back and then we go to 4. And after 4, we also could not go more deeper. So therefore we then again went back to 0 and then we reached 2. So if I printed the visited vertex in this depth first traversal, then it would be 0, 1, 3, 4, and 2. To do depth first traversal, we will be taking a help of a list, and the length of this list will be equal to the number of vertices in this graph. In this case, the number of vertices in this graph is 5. The length of the list will be 5, and this list will initially contain the value of false by default, signifying that none of the vertices have yet been traversed because we have not yet started the depth first traversal. So as we traverse a vertex, its corresponding index in this list will be changing from false to true. Like suppose if we start from 0, we traverse 0. So therefore the index 0 will change from false to true, signifying that vertex 0 has been traversed. The importance of this is that it will avoid us doing back traversal. Like if we started from 0 and reached 1, then when I reach 1, there are 3 ways. That is, I can go to 3, 4, or 0. So our algorithm should be efficient enough that it recognizes that 0 has been traversed, and the algorithm should not take this path. Okay, it should not take this path. It can either go to 3 or 4. So to remember that it has already traversed 0, therefore I have a list in which the position of the index containing the index 0, which was initially false, will be changed to true, and when we have reached 1, we try to go to 0, but the 0th index is true, so we find that it has already been traversed, so we do not go to 0. So therefore, in depth first traversal, we go to those nodes which have not been traversed or whose indexes are false. So if we see thing from the viewpoint of this list, then you can see that we started from 0 and we reached 1. Then we saw the key 1 and we saw that the key 1 has the list 0, 3, and 4, but the value of index 0 is 2, therefore we did not go to 0. So therefore we then go to 3. Then having done that, we again see the key 3, and by the way, the index 3 also gets changed to true, and so does the index 1. So we go to we go to key 3. We see that a list is associated with key 3, which has an element 0, but 0 is already true in this list, so we do not traverse 0 again. And since we cannot go more further deeper, therefore we traverse back, and then we go to 4. So we again go to 4, key 4, and then we see that 4 doesn't have anything, therefore we again traverse back, and we go to 2. So let's now code it. So first I am gonna import default text from collections. Now I'm going to define a class graph, and in this class graph I will be defining a constructor, and this n basically denotes the number of vertices in this graph. So we need to pass this n as an input while making an object of this class. So whenever we shall be creating an object of this class, we shall pass this n as an input, signifying that this n is the number of vertices in the graph, because we have to make a Boolean list which would contain false by default, signifying that we have not yet started our traversal. So now I'm going to assign n to num vertex, and then I'm going to use the imported default dict from collections to make a list by default whenever we create a key of this dictionary. So this graph is actually a dictionary which would be, and whenever we would be creating a key for this dictionary, a list corresponding to that key, an empty list corresponding to that key would be generated. So now we shall be defining a function which would be responsible for adding the edges. Basically we would be creating the graph structure, and for that this add edge function would take care of it. So now I am going to say self.graphView.append. So whenever I write self.graphView, this u basically denotes a key. So you see that we have not initialized our dictionary with key u. So whenever we say like this self.graphView, which means it would dynamically create a key u, and it would attach an empty list to that u, and then append this v into that empty list, and it would look something like this, that u is the key, and this v, which is the value inside this list that gets created whenever we define a key for the dictionary graph. So now we are interested in making the graph structure. So I'm going to define a object of this class graph, and I am going to say g equals to graph5, and I pass value of number of vertices here. Number of vertices shall be 5, and then I shall be using the add edge function to make the structure of the graph. So I added an edge from vertex 0 to vertex 1. So whenever I use the function add edge, then this is going to dynamically create a key. Like when I first time use this, then it's gonna attach, it's gonna use 0 as the key, and 1 will be appended to the list, the empty list that got created when I used this value 0 first time, and again 2 got appended in that list. Then again I created the key 1, and with that key 1 I appended the value 3 inside the list corresponding to key 1. Then I appended the value 4, and the story goes the same. And the final dictionary that would be created is exactly same as this, or I can say that the final dictionary that I want is this. So initially, while creating the structure of this graph, this dictionary won't look like this. It would be looking like this, because I have passed the values 0, 1, and 3 only as the key, and corresponding to these keys, I have appended these values inside this list corresponding to the keys. But this dictionary would be eventually created by the end of the program while we write the entire code. Or I can just print the result here of to just see what the dictionary looks like at this stage. So I print g.graph and save this, and if I run this, then you can see that the present graph is key 0, 1, and 3. I also want the key 4 and the key 2 in it, and that would eventually get created by the end of this code. Let's see that. Now to do that for search, or to do that for traversal, I'm going to define a function DFS, and I will be passing the root value, like from where I want to do my depth first traversal. I will be doing from the root. So I will be defining the root while I call this DFS function in the main, and then I got to define a Boolean list which will be printing the value false, and the size of this Boolean list will be equal to the number of vertex in this graph. Now, since I have visited the root, therefore I shall write change the value from false to true in that index in the visited list, in which the index is same as that of the root. So if our root starts from 0, as in this example, so visited 0 will be changed to true. And then I'm interested in printing the traversed nodes. So since root is traversed here, so it will print the root. Now I will be making use of another function, which is a helper function actually, called DFS help, and I have not yet defined it. I will be defining it. So in this DFS help, we pass the visited list, that is the visited list in which the root index has been changed to true. Because this is the new visited list that we need to pass in this DFS help function. And remember that you have to depth first traversal by using recursion, because that's how you do depth first traversal. There is another iterative way of doing depth first traversal that I'm going to talk about in a later video, but for this video I'm going to do recursion. Or I should say it's not particularly recursion, because I'm not calling DFS here. I'm calling another function DFS help here. If I had called DFS help here, if I had called the same function here, then it would have been called recursion, but now it's not recursion. We are just making use of another function here. So now let's code the DFS help function. Now since I'm passing the root and visited as the parameter to this DFS help function, therefore I am gonna say I'm going to iterate over this self.graph v, and this v is initially the root that I passed here. So this is root and this is the visited list that I passed here, which means if I pass the root as the index 0, here if I pass index 0, then it's gonna change the value of index 0 of visited list to true, and then it's gonna call DFS help function. And in this DFS help function, it's going to pass 0 and visited list. And now when it goes to this function here, it iterates over self.graph, and here root is passed, which means root is 0, so 0 is passed. So it will iterate over the value corresponding to key 0. So the value corresponding to key 0 is this list. So it will be iterating over this list having elements 1 and 2. So now it's gonna take the first element, and like in this case the first element is 1, and it's gonna say if we have not yet visited 1, and that's it's gonna check by watching the visited list. So in this visited list, if the index 1 is false, which means 1 has not been visited, so in that case we need to visit it. Therefore, in order to visit it, I am gonna change its visited index to true, and I'm going to print it. So here 1 will be printed, and after this I need to go as deep as possible. So now since I have already printed 1, which means now I have to take the reference of 1, the reference, or I should say I should take the help of this key 1, and I should see whatever is in this list corresponding to key 1, because we have to go as deep as possible. And also in this visited list, the values of 0 and 1 will be changed to true because they have been visited. So from 1 we need to go as deep as possible, and that is we have to go to 3. And that I can do by making use of the key 1. Therefore I need to call this DFS help function recursively, and I will be passing I here. This I signifies 1 here, and the visited list, the newly visited list in which 0 and 1 indexes have been changed to true. So 1 has been passed here and the visited list has been passed here. So again the function reruns, and this time it iterates over the list corresponding to key 1, and in that list 3, 4 and 0 are present. So first it is going to iterate, so first it's going to take 3. So if visited I equals to false, yes, 3 has not yet been visited, so it changes its index in visited list true and then prints 3. Then it again calls DFS help function, and in this again DFS help function, 3 is passed and the newly visited that list is passed. And in this visited list, 0, 1, and 3 indexes have been changed to true, which means now when this function reruns, so it's going to iterate over the value corresponding to key 3, and that is the list containing only element 0. So it iterates over 0. For I in self.graph here in B, 3 is passed, so it iterates over the list corresponding to key 3, and it sees that it first finds 0. So it checks if visited 0 equals to false. So visited 0 is true, therefore it does not visit it again. All right. So if I show this through a diagram, then this is the first time when the function was called, and this 0 was passed at the root, and with this the visited list was passed. So here it printed 0, and then it called the function DFS help, and in this DFS help function, B was passed as 0 and the visited list was passed into it. And then this function iterates over the key, iterates over the value corresponding to key 0, that it iterates over this list. So first it identifies 1, it finds 1, so it sees that 1 has not been visited, therefore it visits 1 and prints 1. So after 1 has been printed, it calls itself recursively again, and this time passes the value 1 as the V and the visited list. And this time in this innermost function, it traverses over the value corresponding to key 1. The value corresponding to key 1 is this list. So it first goes through 3. It sees that 3 has not yet been visited, so it visits 3 and prints 3. Now after 3 has been printed, the function again calls itself recursively, and this time it passes V as 3 and the visited list. So it sees the value corresponding to key 3, and that is this, and that is this list which is having 0 as the element. So it iterates over 0, so it sees that 0 has been visited because its index in this list is true, which means 0 has been visited. So the if condition inside this innermost function doesn't run, which means this innermost function has done with itself, and there is no more recursive call here. So therefore it gives its authority back to its caller function, and it comes back to this function. In this function, it has already printed 3, which means in this function the value of I was 3, and it has done with 3, so now it comes to 4. So the value of I becomes 4. So in this function, it sees for I in self.graph 4, here V4 is passed. So here V is 1 only because 1 was passed here. So for I in self.graph 1, so it has already done with I equals to 3. So now it will work with I is equals to 4. So now it checks if 4 is visited or not. 4 is not visited, so it will be printed, and its value in visited list will be changed to true. And then it's going to recursively call itself, and here in place of I, 4 will be passed and the visited list will be passed. Now, which means there will be more function calls here, and this time 4 and visited are passed here. And also see that it has printed 4 after 3, and after that this function was called. So in this function, it again runs from the beginning, that is, it sees for I in self.graph B. So self.graph B, so here it passes 4, but our graph doesn't have a key 4. But as I said, that's why we use default dict. So since we are using default dict, so it will dynamically create a key 4, and it will attach an empty list to it. So if this was the dictionary, then it will dynamically create a key 4 and then attach an empty list to that key. This is the use of default dict. And after that, it will try to iterate over that over the list corresponding to key 4, but that list is empty. So this for loop ends here and now. So since this for loop ends, which means we are done with that function, which means we are done with this innermost function, and therefore it returns its authority to its upper caller function. So again, we are back to this upper caller function. And remember that since we have visited 4, therefore the value of index 4 in this visited list will change from false to true. So now back to this function. It has already iterated over 3, 4, and now it will get hold of the value 0. But since 0 is already visited, how? Because its index in this visited list is true. Therefore, it will not visit it again, and it will not print it. So we are basically done with this function. So therefore, it will return its authority to its upper caller function. And this upper caller function has already iterated over value 1. So now it will iterate over this I will be changed to 2. So 2 is yet not visited. So since I is changed to 2, it sees that 2 is visited or not. So 2 is not visited. Therefore, it will visit 2. That is, it will change the value of index 2 in this visited list to true. Now, for this index 3 would have also been changed to false to true because we had visited it earlier. So now in this function, 2 will be printed. So after 2 is printed, it's again going to call itself recursively, and this time it's going to pass vs2 and also the visited list. So in this function, it reruns from beginning. So it sees for I in self.graph v, but there is no key in this graph with value 2. So it's going to dynamically create that key, and with that key, it's going to append an empty list to it. This key will be added, and with that key, an empty list will be added. But since this list is empty and it tries to iterate over that empty list, so this for loop basically ends here. So therefore, in this function, it basically does nothing and returns its authority to its upper caller function. And in this upper caller function, the for loop ends because it iterated over 1 and 2, and it has nothing to iterate over. So therefore, it will return its authority back to its caller function, which was this. So when we are back to this function, it says that it has no more code left to run. So therefore, our overall function execution is over, and this is how we have done the depth first traversal. So finally, when we call this DFS function in the main and we pass the root, like we want to do our depth first traversal from root 0. So let's save this and let's run this to see what is the result. So you can see that it traverses 0, then 1, then 3, then 4, then 2. So this is the depth first result that we were supposed to get. Okay, so if I print the final graph that got created, then this was, then let's see what comes as the result. Let's save it and let's rerun it. So we see that the final dictionary that we got here, we got a key 2, and with that key 2 an empty list is associated, and we also got a key 4 with that key 4, an empty list is associated. So this is how we actually do the entire process. But this is the case with connected graph. So in this example, the graph was connected. That is, from a root, you could basically go to every other vertex. But what if the graph was not connected? For example, if I slightly modify this graph, initially this is connected graph because from root we can basically move to every other vertex. What if it was a disconnected graph? So this is the disconnected graph. That is, we can go to every vertex from root, but we cannot go to 5. Since we cannot go to 5 from 0, so therefore this is a disconnected directed graph. Directed means there is a particular direction of traversal. Like from 0 you can travel to 1, but from 1 you cannot travel to 0. So this is a disconnected directed graph. So in this disconnected graph, you cannot apply the same logic that I applied for connected graph. So I will be doing a slight modification there. So now the output of this depth first traversal should be 0, 1, 3, 4, 2, and 5. So if I add the new connection here, you will see that when I print the output of this DFS traversal, it won't be printing 5. So I just ran this program and you see that it printed 0, 1, 3, 4, 2, and it did not go to 5 because from 0 you can basically cannot go to 5. So I have to change the code a bit. So you can see that here I added a for loop here. So this for loop basically it iterates from 0 till the number of vertices. So in this case, the number of vertices gets changed to 6 because I've added 5. So it iterates from 0, 1, 2, 3, 4, and 5. Because this list operation is going to create a list from 0 to 5, that is 0, 1, 2, 3, 4, and 5, containing 6 elements. First it chooses 1. This I is 1, so it is that if visited I equals to false. So yes, first it chooses 0. So first visited 0 is false, which means it is going to call DFS help function and passes 0 and the visited list. And in this DFS help function, I'm gonna change a bit and we remove those print statement and the value change of the value visited list here. I am gonna put them here. So first time 0 was passed here, so it then changed the value of 0th index in visited list to true, and it then printed 0. And basically my motto is that this will be doing the same thing as earlier, but in case any vertex is not reachable from root, then it's also gonna take that into consideration. How? Let's see that. So first 0 is passed and 0th index in which it is changed to 2, then 0 is printed, and then for I in self.graph v. So self.graph 0. So corresponding to 0, 1, and 2 is present. So it again goes to 1 and 2. It first goes to 1 and corresponding to 1, 3 and 4 is present. So it goes to 3 and 4. And then it comes back and then goes to 2. So 0, 1, 3, 4, and 2 have been traversed. The only thing left is 5. So when this DFS help function has completely done with itself, then it comes back to here. So when it comes back to this DFS function and this I was 0, so this I gets changed to 1. So if visited 1 is true, it's false. No, visited 1 is true because 1 got visited in this function. So visited 1 is true, therefore this if function doesn't run, therefore I gets changed to 2. So visited I is false, no, because visited 2 is true. Again this I gets changed to 3. So again visited 3 is not false, which means I gets to 4. Again visited 4 is not false. Again I gets changed to 5. So when I gets changed to 5 and it checks if visited 5 is false or not. Yes, visited 5 is false because 5 did not get visited in this function. So visited 5 is false, therefore it calls this DFS help function and this passes the value of 5 and the visited list here. So when 5 comes here, it prints change the index of 5 in visited to true and prints 5, and it does this for loop for that key 5. Corresponding to key 5, 4 is present because remember in the example I showed the connection 5 to 4. Okay, so 4 is present in that list for key 5, but 4 is visited, which means visited 4 is not false, it is true. Therefore this for loop gets executed for the function in which 5 is passed as v. So we are done with that function in which 5 was passed as v. Therefore it comes back to this function, this DFS function. I was 5, and that was the last value for the list created by this operation. So the last value was 5 because it ranged from 0, 1, 2, 3, 4, and 5, 6 values. Okay, so I was 5, and since 5 was last value, therefore this for loop terminates. Okay, this for loop gets over, which means this DFS function has completely done with itself. So if I change this value to 6, because there are now 6 vertices. Now if you do the depth first traversal from 0th index and you save this program and you run this, you can see that now it has also traversed 5. okay, and a list, and in this dictionary corresponding to key 5, a list was stored in which in that list the element 4 was present. So you can see how things got modified here. So it also travels 5 here. So for disconnected graph, this works very well. So I hope you understood this video. Like and share this video, subscribe to the channel, and thanks for watching.